In this video, you're going to learn how to apply the negative power rule law of exponents to exponential expressions in order to write an equivalent expression. But before we do this, I want to go ahead and give you a brief background on something that you are actually quite familiar with, and you'll realize that you know a lot about this already. If you remember the 5th grade where you learned something called scientific notation, that was our first introduction into dealing with negative powers. And if you remember, what scientific notation basically was a way for us to write really large or really small numbers as a multiple of 10 to some power. And so, for example, we have this first one that's written in scientific notation that is 3 times 10 to the power of 2. And you know that basically is the same thing as saying 3 times 100, but you may have learned a little shortcut when you were younger of just basically saying, oh, that's the same thing as 300. And that would be correct. Now, when we had something that was to the negative power, the shortcut you might have learned was to move that decimal point. And the reason you did that is basically because this essentially is the same thing as saying 3 times 1/100th. And so what you ended up with as your product would be 3/100ths, right? And so that is what scientific notation is. And scientific notation had us applying the negative power rule for numbers that were smaller than 1. The negative power rule tells us that whenever we have a base raised to a negative power, what we really have is a number that's less than 1. So instead of this being 3 to the negative 2, the way we get rid of that negative exponent is by putting it as a fraction and flipping it so that you have 1/3 squared. These two are actually equivalent expressions. They mean the very same thing. So when we look at the next expression, x raised to the power of negative b, we essentially put x to the power of positive b over 1. And all of a sudden now we don't have a negative exponent. And so a lot of times it's easier for us to simplify an expression when we don't have negative exponents to deal with. So these two become equivalent expressions. When we look at the next example, we have 7 over a raised to the power of negative 4. Now before I go ahead and get rid of my negative exponent here, I want to make sure I distribute this negative 4 to both my numerator and my denominator, just so that you can see very clearly what's going to happen. And basically what I have here is 7 to the power of negative 4 over a to the power of negative 4. And in order to get rid of these negative exponents, I have to put this over 1, and this one is already in the denominator spot, so what I would have to do is flip this and put it in the numerator spot, and that would go ahead and get rid of that exponent. So what I have here is a to the power of positive 4 when I'm done simplifying it, and 7 to the power of positive 4. Now I could have easily just told you in the beginning, oh yeah, because we have our parentheses and this negative 4 applies to the entire thing, what we can do is just flip our numerator into our denominator and vice versa. And then we would have just had a over 7 raised to the power of positive 4. Now you actually understand what really happens behind the scenes.